Welcome to the Stenner Pump Company in Jacksonville, Florida. Hi, I'm Bill Neal.
And I'm Karen Wake. Stenner Pump manufactures peristaltic metering pumps, which are utilized worldwide to inject liquid solutions, mainly for treating water in residential, commercial, and industrial applications. And the company has been in business for over half a century.
Today we're going to take a tour of the factory to see how the pumps are made. Let's go inside.
We're in the main building where production comes together.
And with us now is Michael Kincaid, the Executive Vice President of the Stenner Pump Company. Michael, this is quite an operation.
Well, we're very proud of the company. Our staff here does a great job.
And the company has been around for over 50 years.
Yes, the company was established as G.H. Stenner and Company, Incorporated in 1957 here in Jacksonville, Florida by Gustav and Helen Stenner. This is one of the first prototypes made of bronze, and it weighs approximately 25 pounds. As the pump was developed, a mixture of metal and plastics were used until eventually the housings were made of polycarbonate plastic, reducing the weight to 8 pounds. This one is the classic model.
These are peristaltic pumps. They're reliable and accurate. Peristalsis is a system of rollers pressing against a flexible tube that creates a vacuum as the rollers turn and moves the solution through the tube.
Yes, let me show you. The precise design and rugged construction has contributed to their success in the field. In 1995, Tim Ware purchased the company and established an employee stock option program where the employees own 49% of the company.
In 2007, the name was changed to Stenner Pump Company. To facilitate growth and product distribution, Mr. Ware set up additional manufacturing plants in New York and Kansas.
A majority of the pump components are made at the factory, and vertical integration allows better inventory, quality control, and delivery. Let's see how the raw materials are converted into parts used in the final product.
This is the molding building, and these machines behind us are called injection molding machines. Here is where the plastic parts for the pumps are made.
These plastic pellets are the raw materials used to make some of the parts. The hoppers on top of the presses are used to collect and dry the pellets. The pellets are then gravity fed into a heated barrel where an auger type screw feeds the melted plastic, where as much as 30,000 pounds of pressure pushes the plastic material into a steel mold. Water is run through the lines in the mold to cool the plastic part, and once the process is complete, the mold opens and a robotic arm picks the part out and drops it onto a conveyor. Yep, fresh off the press and still a little hot.
More than 50 different parts are molded in this building for use in the production cycle. By manufacturing so many of their own parts, Stenner reduces delays in the production process and has better quality control from start to finish.
The Stenner pump is often installed in dimly lit locations like pump rooms or basements. Many customers have said that the numbers on the pump's dial ring needed to be easily visible for adjusting the pump to the desired setting. So Stenner developed the pad printing process. The numbers are white instead of the same color as the pump.
It took over 2 years to implement this process because of the difficult angle on the part itself, but it's just an example of how this company is inspired by their customers.
Now we're going to my favorite area, the tooling building. This is the tooling building, and there are 3 different operations taking place here: mold making, machining, and robotics. Behind me are the computer-controlled machines called the CNC Swiss turn lathe. 12-foot lengths of bar stock are loaded into the machine, controlled by a pre-existing program, which will automatically cut steel, brass, and plastic parts. The CNC machines can run throughout the night or weekend without an operator. There are several parts made by the CNC lathes that are also used in production.
This is the mold department, where metal molds are manufactured, maintained, and cleaned by the mold maker team. Some of these molds are very heavy and can weigh as much as 1,500 pounds. When Stenner develops a new product, Their designers use CAD to design the molds to make the individual parts. The tooling department uses CAD-CAM to send a tooling program to the CNC machine to make mold components. After a molding production run, the molds are returned to the tooling room for preventive maintenance inspection and set up for the next production run.
So we're here in the robotics room, and this is really cool. Michael, can you tell us what's going on here?
The robots are used to assemble parts that will be used for production. As you can see, vibratory bowls and conveyors automatically feed the robot, which picks up the parts and assembles them. They are accurate and fast and provide repeatable quality.
How long will the robot keep going?
This robot will run as long as parts are fed and can operate 24/7, similar to the CNC machines.
So was the number of staff reduced with the introduction of robotics?
No jobs were eliminated. Instead, the personnel were cross-trained for other assembly work, including new products. The robots and the training allowed us to increase our capacity without changing the number of production personnel employed here in Jacksonville.
That works out well for everybody.
Absolutely.
We're back in the main building, which includes the warehouse, parts and assembly station, shipping, repairs, research and development, and the administrative offices.
Now this is where everything comes together. The parts are moved from the tooling building to the main building, where they are assembled into sub-assemblies to make a finished pump. In the warehouse, the plastic, metal, and purchase parts are received, quality checked, and stored for the final stages of assembly.
Next to the warehouse are the assembly stations, where sub-assemblies are made to eventually make a specific pump model. We're going to follow the process for making the Classic Series single-head pump. The three main components are the motor, feed rate control, and pump head.
This is the motor assembly station. With the use of precision air presses, pneumatic crimpers, and electric screwdrivers with vibratory bowls, each motor is assembled by an operator and 100% tested. The finished motors are placed into bins, the bins are placed on labeled flow racks, and the motors are ready for selection in the final assembly.
The next sub-assembly, the feed rate control, is a mechanical component which regulates the output of the pump and has the external dial ring, where we saw the numbers pad printed during the tour of the molding department. An operator assembles the component using presses and electric screwdrivers set to a precise torque setting as part of ensuring the component pieces function together properly. The feed rates indexing parts and assemblies are checked again at this point for proper performance. The final step in making the feed rate control is placing all the components in the housing and closing it. The feed rates are then placed in bins and put in the flow racks, ready for selection in the final assembly.
The last sub-assembly on our tour of the making of the Classic Series pump is the pump head, which includes the pump tube. At the pump tube assembly station, a semi-automated system allows the operator to simply place the parts in and let the machine do the work. The repeatability is much higher and much faster than assembling the tube by hand. After the tube housing and roller assembly are attached to the main shaft, the assembler uses a pump motor to load the pump tube into the pump head. The finished pump heads are put into bins, placed on the labeling flow racks, and are ready for selection in the final assembly.
The final step to make a completed pump is to select the motor, feed rate control, and pump head sub-assemblies that match the order. The sub-assemblies are snapped together, tested, labeled, and moved to the boxing area.
In the boxing area, the accessory kit and box labels are pulled to complete and box the pump. A box folding and taping machine seals each box, which is then delivered to the shipping area. Near the shipping area, the parts department puts together pump accessory kits, service kits, and packaged parts.
The last stop is the shipping department, where pumps and parts are packaged or palletized to be shipped to customers around the world. Behind me, you can see another area in the main building. the repair area for pump reconditioning and warranty work. Stenner pumps have a warranty return rate of less than 0.25%. Well, that wraps up the tour. Thank you, Michael.
It was my pleasure. Stenner is committed to customer satisfaction, quality products, and timely deliveries.
Yeah, well, I'm sure the audience found the company's presentation very informative. Thanks, Michael.